Welcome. We're so glad you're here. My name is Whitney Lee, and I'm a CNCF ambassador, and I'm here with the creator of Flagger, Stefan. Stefan, will you introduce yourself, please?
Hi everyone, I'm Stefan Prodan. I'm a Flux core maintainer, and Flagger, which is a sub-project of Flux, is one of my babies.
I love that. So Stefan and I just had a conversation that was almost 2 hours long about Flagger. And we're here to give you a recap of that long conversation. So before we talk about Flagger, we have to give some context. So what was the world like before Flagger that caused it to get created? What were some problems that were happening?
When you deploy something new and you don't want to, impact everybody with your new version, if you are, let's say, a GitOps practitioner, you would update your new version in the Git repo, and you would, modify a custom resource that does routing, like a Istio route or gateway API route and so on, and you move some traffic to the new version, you commit it, wait for things to happen, look at your Grafana dashboards, then, go back to Git, add more traffic and so on, right? Flagger tries to solve this in a fully automated way. So you don't need to look at dashboards and change it.
You're jumping ahead, friend. We're doing context right now. So the problem was that deployments were a tedious manual process. If you're doing them in a safe way, at least, it was tedious and manual, or it was unsafe, one of those two things. And so then this Flagger came out, and with it, the idea of progressive delivery. So what I knew about Flagger going into our conversation today, it's a progressive delivery tool. But can we say, what is progressive delivery?
Progressive delivery is an umbrella term for advanced deployment strategies. It can be a Canary deployment, it can be an A/B test, and so on.
So when you say Flagger is a progressive delivery tool, it's a tool that does advanced deployment strategies, helps you do advanced deployment strategies in Kubernetes. And I suppose we could say it automates those things so that you can say what you want to happen and then walk away and trust that Flagger and Kubernetes together will make it happen. Is that accurate?
Yes, and I will also add and Prometheus.
And Prometheus. And a networking layer. We're going to talk about the L7 piece that Flagger relies on.
Yes, so Flagger is not a proxy on its own. It's an orchestrator. So in order for Flagger to route traffic from one version to another, or to mirror traffic, or to do all things around traffic for your users, it relies on layer 7 tooling, like a service mesh or an ingress controller. This is their expression in the Kubernetes space.
So let's talk about how it works. A custom resource that it introduces into Kubernetes called a Canary. We talk about this Canary custom resource.
A Canary custom resource resembles a lot to an horizontal pod autoscaler custom resource. Inside the Canary, you point Flagger to your Kubernetes deployment and tell Flagger, hey, I want to do this type of rollout for this Kubernetes deployment. And you can point also Flagger to your horizontal pod autoscaler that, scales your application while it receives traffic. The Canary also contains details around how you want to do the progressive delivery, which percentage, what tests should be run, webhooks, and so on.
So you have one resource where you define all of that stuff, and that resource supports lots of kinds of advanced traffic management, or really advanced rollouts, or advanced ways to deploy application. So we talked through these 5 different types. The first one we said was basic blue-green deployment. What does that mean?
It means that when, let's say, Flux, or maybe you do a Helm upgrade, or you kubectl apply for your new version, Flagger will take that version. It will not expose all your users directly to it. It will take the new version. It will scale the version up from 0 to 1. It waits for horizontal pod autoscaler to set the minimum replicas. Then Flagger, as instructed in the Canary custom resource, it will run end-to-end tests. It can look at metrics while it runs the end-to-end test. It can run a load test to mimic actual traffic. The idea is it does not receive live traffic. It only you run these tests, you look at the metrics, and if everything is good, all the live traffic goes from the old version to the new version at once. And for this, Flagger does not require a service mesh or a particular ingress controller. It works with your Kubernetes CNI plugins.
That makes sense, because if you're not routing a small percentage of your traffic, you're just booming all the way from one to another. You wouldn't need that advanced traffic layer. So one thing I'm interested in before we get through the other strategies of deployment, you said that like the testing happens and the Flagger is able to verify that the green deployment's ready before moving all the traffic over. So let's talk about the ways that Flagger is able to verify success and that something is ready. So what are some mechanisms that Flagger uses to be able to know that a deployment is ready to receive more traffic?
Assuming you use the Flagger built-in load tester, you will tell Flagger, hey, now generate traffic from my new version.
Oh.
So this is called in Flagger the webhook. Flagger calls this webhook for this particular implementation, which is load testing. And you can have your own load testing tool implemented there and so on. But Flagger comes with a load test by default. While the load test is running, Flagger will look at Prometheus metrics by default, but you can also have your own custom metrics for other observability tools beyond Prometheus. The idea is, by default, Flagger looks at HTTP error rate and latency, and you can set thresholds for that and so on. So it starts this load test, then it looks at the metrics to figure out, is the new version in parameters. You probably have a service level objective where you say only 1% of all the traffic is allowed to fail. If it fails more than 1%, the new version is not good, and so on. Besides this kind of metrics, there is also a custom resource called metrics template, where you can define your own metric queries for various observability tools like Google, Stackdriver, CloudWatch.
Datadog, you said, I believe. Yeah.
Datadog, Dynatrace. There are a bunch of integrations there. So that's one way to extend the Flagger analysis. Another way is through having your own custom tooling that looks at the new application and reports back to Flagger if things are okay or not. And this type of extension is through webhooks, where Flagger at any point in time during the rollout calls your tool and asks, is this okay? Yes or no? And it advances or rolls back.
So I think that having that color really helps when we go through these different deployment strategies. So we have the basic blue-green, where we can use these sorts of things to decide when to switch from the older version of the app to the newer version. Then we have blue-green mirroring. What's that one?
In blue-green mirroring, instead of trying to fake the traffic with the load test, you actually use real traffic, but you don't expose your users in any way to the response of the new version. Flagger talks to the layer 7 implementation, let's say Istio, and tells Istio, clone all this traffic to the new version. Then Flagger looks at metrics and so on. And this type of mirroring is great, but only if the app is stateless and does not do, credit card transactions and stuff like that, which would result in a major pain for users.
That makes a lot of sense. And then you taught me about a deployment style that's new to me, which is called an A/B deployment. What's an A/B deployment?
It's a way to segment your users. You decide the segment of the users that will be used as guinea pigs, as your testers. And you can do this kind of segmentation based on a cookie. Maybe you have an insiders program and people say, yes, I want to test the new versions, and give them some benefits or whatever. Then you assign a cookie or an HTTP header to that segment of your users, and you tell Flagger all the users with this header or cookie should be used to test the new version. So all the tests, all the metrics and so on are based on real traffic from real users, but they are a smaller percentage of your whole user base, right? You don't expose to all the users, only to that particular segment. And that can be location, a custom cookie, everything that's it's in the web browser user agent, and so on.
And then maybe unsurprisingly, since our resource is called a Canary, we have a Canary deployment. What's a Canary deployment do?
Canary deployment, you route a percentage of the traffic from the old version to the new version, and you keep increasing that percentage. You can start very small, let's say 1%. You read some metrics, if everything goes fine, you keep increasing that traffic. This is a procedure on which you slowly expose users to the new version. If any point in time it fails, the latency goes off the charts or error rate increases, then you slowly move them back, right? It's something that Kubernetes itself cannot do, and it's probably the safest way to do deployments nowadays on Kubernetes if you have a service mesh or ingress controller besides Flagger.
And one thing I learned from a question during our longer stream from a viewer was that if something fails only one time, you can set a failure limit. So you could say, this needs to fail 5 times in a row, and then I'm going to start shifting traffic to account for the fact that there are sometimes little anomalies that could happen that might cause a temporary failure that wouldn't indicate a real failure that would necessitate rolling back.
A good example here is maybe the horizontal pod autoscaler is stuck, is slow. It has a latency when it reads the metrics, and maybe at some time, yes, you'll get longer latency, but if that latency is not persistent, failing the SLO for a long period of time, more than 1 or 2 minutes, then you may want to go forward with the deployment.
And then we talked about, you described the problem well. So the Canary deployment is a cool concept, and like you just said, the safest way to go. So it's wonderful. But each time the same user is clicking on a different page of the website, the way it's set up now, they might go back and forth between version 1 and version 2, which could break their experience and break the app for them. So in that case, you want to use a Canary deployment that has session affinity. Will you describe that, please?
So with session affinity, you make sure that once a user ends up on the new version, sticks to the new version, so it doesn't flip between versions. A good example here is when you access a web page, usually you download the HTML, the CSS, the JavaScript. You don't want the new HTML with the old CSS, right? Everything will be mixed up. So the idea here with session affinity is that once the user ends up on the new version, Flagger instructs the proxy, the L7 proxy, to inject a cookie. So when the user comes back, the next request will have that cookie, and the load balancer will make sure every time it goes to the new version until the Canary analysis is over. You keep users on the new version, and their experience will be okay.
And it's worth saying here that Flagger injects the cookie. So for that to happen, you need to add an L7 technology that supports cookie injection. And similarly, the blue-green mirroring, you need to make sure you are using a networking layer that supports traffic mirroring to be able to take full advantage of those technologies by Flagger. But you painted this really lovely picture of someone who, before the end of the day on Friday, decides to start their rolling out a new version of the application. And then they enjoy their nice, long, lovely weekend and come back on Monday. And either the application's successful, or maybe it's even not successful and it rolled back. But either way, it's in a safe spot and something that they don't have to think about at all during the rollout process.
The main goal of Flagger is to, allow people to make mistakes and not being afraid of making mistakes. Especially with continuous delivery, you are encouraged to ship every single change as fast as possible. It should end up in production. But if it ends up in production and users are unhappy, then you'll not be tempted to do this, continuous delivery stuff. So Flagger, it's at the end of the pipeline. It's after, Flux or whatever tool you are doing does the deployment. Flagger does the actual release, and it makes sure, if the release fails, some metric fails, whatever, it rolls back, moves all the traffic to the older version, and then it sends you an alert. And you can send an alert to Slack, Microsoft Teams. There's a bunch of integrations there. It exposes its own Prometheus metrics and so on. And it lets you know, hey, the new version has failed. I've rolled it back. If you are not afraid of deploying Friday, you can actually deploy Friday, and Monday morning you'll see, the alert, oh, my Friday deployment has failed, has been rolled back. Let's look into it and see how we can fix it. Right? It gives you that confidence of, yes, you can make mistakes. You'll not break everyone's experience by making that.
I have two more questions for you. The first one is, you said that Flagger is a sub-project of Flux. So do you have to have Flux installed to be able to use Flagger?
Flagger is designed to work with Flux and is designed to work with GitOps, but it can be used with any other tool. It can be used with Argo, it can be used with Jenkins, with a Helm upgrade. Even if design is made to be GitOps friendly, you don't need to buy into GitOps to use Flagger. You can use it with any tool that doesn't apply in the end. It's totally independent in terms of functionality. It's a great add-on if you do continuous delivery with Flux.
And then my last question is, if I'm a viewer right now and I want to try it out, where should I go next?
We have a website, flagger.app, and there is also a subdomain, docs.flagger.app, where we have the tutorials, guides. We explain all the concepts in Flagger, and we, based on whatever ingress, service mesh, observability tool you have, you get to pick and choose from there, and hopefully, you'll have a smooth sailing, and you can implement Flagger in your own organization. Flagger is around 6 years now, has been adopted in huge organizations, but also by startups and very small teams. It's a great tool to have in your Kubernetes cluster if you want to deploy on a Friday.
If you want to enjoy your weekends, yeah. All right. Thank you so much, Stefan, for sharing your time and expertise today. And thanks everyone who's watched.
Thank you very much for inviting me. Thank you.
Bye.